course can have the substitution, so it will simply be the to obtain the target molecule. So an alkylation in the presence of lithium D LDA and using this carboxylic acid or the ester here. However, we can also make such a, so it is AR, so reagents for A1, but we can also make such a trick, and it is the solution that is developed, that has been developed in the book, and which we can see such a with simply the carbonyl function here. So then we'll have O1 and it will be the acceptor 1, which is also very good and for that kind of chemistry. Once more a similar approach as here, so using this reagent and then we will have simply the addition reaction, in which we will obtain directly target molecule, because here by the alkylation then we'll not have a double bond here but a single, so a target molecule with a single bond here. We'll have a single bond here, which then we should, that will be a product which we should that dehydration, so we have here hydrogens, and we should oxidize this product to a target molecule. So it will land somewhere near the target molecule, but not necessary in the direct place of the target molecule. And then once more, so let's what if we preserve here the original, once more, not here, we are not here, yes, so once more, if we have here and then by this connection we will have once more A, so this connection A once more, and with such a polarization then we'll have aromatic function here, carboxylic function here, and a minus, so a D1, because we discussed that previously, so that one will be D2, and here we have acceptor 3, and then we will have once more something like that. So so synton to reagent, and we'll have minus, and then aromatic and carboxylic. And once more, if we use here a base, yes, so we should put here hydrogen, yes, hydrogen, yes, and like that. So we'll have carbanion and nucleophilic attack to that will make a product just raw, so aromatic, and then we'll have a nitro group here and a carboxylic, so we see that we are obtaining directly a target molecule as a product. Once more, we can ask here a similar question of the no, that's okay, so we do not have malonate here, that's okay, and let's remove that one. And let's try another disconnection at the second shoulder of that compound. So similarly to that, we can make this disconnection. Let's say it will be disconnection 2. Once more, we can try two different A and B, and we see that what is a typical synton in that position, O1, so D2, because D2 is natural polarization. So D2, we have something like that. Okay, it's getting off here. So we'll have minus, and everybody can see that it is 0, 1, 2. So D2 synton, which is a natural polarization of the carboxylic group, and then this original compound. And once more, we can see that what we need is at that position is an acceptor synton. Acceptor synton will ask what will be the number location of that synton. Once more, let's go to the reagent. And in the reagent part we can see that if we once more will draw the aromatic function, so 1, 2, 3, it will be A3, so 0, 1, but of course here A3, 2, 3, so acceptor 3. Once more, acceptor 3 is just a normal standard type of reactivity of compounds, A3. So what we'll have here, A3. So that is an A3 synton, and donor 2. So once more, the carboxylic function to preserve that kind of notation, and put it here simply hydrogen, and carbonyl loop 1, 2, O1, 2. So at position, yes, something is wrong here, carboxyl. Yes, and we can see that simply the disconnection was not correct. The disconnection is correct, by my notation is not correct. So we'll get rid of that. Yes, we get rid of that, and hydrogen here. Now everybody can see. So D2. So by remembering the synton notation, a full synton notation, we can see very quickly that our structures are not well redrawn, simply redrawn from one side to the second side of the table. And once more, a base here, removal of that hydrogen, and we are obtaining minus, so carbanion, which should react with that. It is a synton, but for the reagent I must put here a double bond, so a double bond here, and once more a Michael. So Michael addition will brought me to the target molecule here, to a target molecule here. I'm not counting the targets now because it's very complicated, so but basically I should remember what number is here. So it is not the same target molecule that we have drawn the first on the first table today. And once more I have this sub-target molecule, or let's put it sub-target molecule. So I should once more come with that to that table. By retrosynthetic analysis, so from reagent to the syntons, and once more the disconnection. Let's put the disconnection here. And once more the natural part will be like that, so I'll write to preserve that one minus here. So plus and minus here, because basically I should preserve that type of notation to be formally well written. And here I'll have that kind of disconnection, so a minus, it will be D2 synton, so a synton D2, and here aromatic and a plus, and I'm asking acceptor, but what kind of acceptor synton? What kind of the acceptor synton is it here? And once more, to get rid of that, I must get rid of that here. And coming from this to reagent, so synton to reagent, and that kind of chemistry, so that kind is very well known. So the ending will be the hydrogen and nitro, so a nitro here, not a carbon but a nitrogen atom, plus minus, and if we remove this hydrogen by the action of base, what we'll obtain here, we'll obtain once more reversible process. We are obtaining a carbanion, so we are using a nitromethene, once more nitromethene, and here once more the similar trick as previously, so we are using that kind of chemistry, so a carbonyl function, so it will be A1, so acceptor 1, so A and D is very similar in my writing, so basically this carbanion, the addition to that group will give me this sub-target molecule that was written on my previous table in that position. Uh, so we can see the tricks once more. We can ask a question about reagents, and then the second possibility. So once more come to the so once more we can come to this compound and carboxylic function and nitro here. So let's put it in the chemical way. So let's put it like that. A nitro group, and once more let's start from this connection. So this connection A, and in this connection A we'll have, once more we are asking the question, this one or this one, and we see that almost in every synthesis approach that we are discussing here, we are using this trick of putting this carbonyl group, and which constructs here a very nice O1, so acceptor 1 synton, and then it is very reactive. So carbonyl function is very important in organic chemistry. Carbonyl function is very important in organic chemistry, and it provides a very selective reactions and very reactive reagent for what we are needing. So let's try this connection one more. See, so we'll have a minus here, and once more what kind of that will be, and here aromatic and carboxylic with that plus here, and once more synton to reagent, so aromatic, and once more we see that this will be of acceptor 01 to acceptor 3. So I've said about carbonyl function is not the case, it is not the case, it's just a Michael reagent with double bond here. Once more we are putting that kind, so A3 representative, and then we have a Cn minus, it will be Cn minus, so with the nucleophile, and we know this will be simply the D0 like synton, and with a reagent like that, potassium or sodium salt of that cyanide, and the reaction, so it is simply nucleophile, the reaction with a target molecule, let's say X, what notation, target molecule X, to find a number for that. And now we can ask a question about that sub-target molecule, but we have already analyzed that chemistry that disconnects that, so we are disconnecting here, and once more we are using that tricky carbonyl function here, and minus O1 to the 2 synton, and then we are going through the malonite chemistry, or even a single carboxylic group derivatives to obtain this molecule. And we can also have here the disconnection B, so I must remove that. and what I'm writing is B, and once more we can have that kind of, we see that with that kind of arrow here, with that kind of arrow, so we obtain simply a plus sign here and a minus sign here. So once more here, O1 to D2, D2, and what we have here, O1, a plus sign here, so once more we are asking about acceptor. What kind of acceptor this will be? And coming to the chemistry. No, with B, yes, with B, of course, yes. So what kind of acceptor is we? I'm putting the question here. And donor 2, of course, donor 2. Donor 2. And then we see that this kind is not okay. Yes, we can see that this kind is not okay because what we can generate here quite easily, so this kind of this connection is not the best one what we have developed. Just we should go no 1, but we should go that do 2, so this connection 2. I'm just writing here, so I'm just writing here further because I need some more space, and we should write it like that. So aromatic, and then we have a minus sign here, and we see that near a group electron withdrawing group we have the acidic hydrogen, so we can generate such a symptom. It will be simply O1, 2, so a donor 2 type, so a donor 2 type chemistry, and then what we will have here will be symptom plus carboxylic function, so this will be acceptor O1, 2, so acceptor 2, and then we go from here to chemistry, from